Welcome back to the Deep Dive. It is Sunday, January 18th, 2026. Today, we are cracking open a source that feels, I don't know, less like a newsletter and more like a diagnostic log for the human operating system.
Huh. That's a really specific way of putting it, but honestly, it fits perfectly. We're looking at a piece called The Weekly Commit, written by an author named Gaurang. And what jumped out at me is that, on the surface, this looks like it's about cooking and football and productivity, but it's actually a cohesive argument about engineering.
Engineering resilience, right.
Yeah.
Specifically, I think we're all used to the soft version of resilience, the motivational posters, the kitten hanging from a branch. But this takes a much harder, much more logical look at what happens when a system crashes.
Exactly. It treats life like a code base. The core question isn't how do I feel better, it's how do I debug this? It's about managing your hardware limitations, clearing cache memory after a failure, and shipping updates, even when the code is still a little buggy.
And to illustrate this, the source gives us this really eclectic stack of data points. We have a story from MasterChef India that honestly just seems to defy physics. Then we have a breakdown of the Manchester Derby, which was just yesterday, and the author's own confession about battling perfectionism.
It's a dense stack, but if you look closely, they're all describing the same thing.
System recovery.
System recovery. How do you get back online when the hardware breaks or the software glitches?
So let's jump right in with the main feature then. The source introduces us to a man named Ratna Tamang. He's a contestant on MasterChef India, and the author frames his story around this concept of hardware limitations.
Right. And in the engineering world, a hardware limitation is usually a hard stop. You can't you can't run a modern simulation on a computer from 1995. The architecture just can't support the request.
But humans are this weird kind of machine because we seem to find workarounds. Ratna Tamang faces what should technically be a fatal error for a chef. He lost both of his hands in a severe electric shock incident.
And just pause on that for a second to really get the context. We aren't talking about a home cook making toast. This is MasterChef. High stakes, high pressure culinary art.
The dexterity required is just off the charts. You're julienning vegetables to millimeter precision. You're deboning fish where one wrong slice ruins the whole thing. You're plating microgreens with tweezers.
It's entirely tactile. Think about how a chef works. The offhand, the one not holding the knife, is actually doing a huge amount of data processing.
Oh, yeah. Stabilizing things.
It's feeling the texture of the dough, gauging the temperature of a steak, stabilizing the onion so it doesn't roll away. The hands are the primary interface between the chef's brain and the food.
So logically, losing that interface is a complete system failure. The workflow should be impossible. And yet, Ratna is there. He's competing.
He is. And the source says he didn't stop cooking. He simply built a new interface.
Built a new interface. That specific phrasing is so powerful.
It's what makes this an engineering story, right? Not just a sad story. He uses a custom metal hook attachment on his forearm.
I'm trying to even visualize the mechanics of that. A hook doesn't have fingers. It doesn't have nerves. How do you chop an onion with a hook?
Well, it's a fascinating study in adaptation.
Yeah.
The hook lets him grip a utensil handle or pin an ingredient down, but the hook is just the peripheral, the real engineering that happened in the software.
In his brain.
In his brain, the motor control. When you or I chop a carrot, we're using fine motor skills from the wrist and fingers. Decades of muscle memory.
Right.
Ratna doesn't have that option. He has to drive the knife using his shoulder, his elbow, his whole torso. He is using gross motor movements to achieve fine motor results.
So he had to rewrite the driver.
He had to completely recode the driver. Imagine trying to type, but you can't use your finger, so you have to move your entire arm to hit each key with a stylus. The computational load to relearn that is just immense. The source calls watching him a masterclass in adaptation.
But I want to push on this a bit. Is the lesson just he worked hard? Because we see people with prosthetics do amazing things, but they don't usually enter competitions where they're judged against people with, full biological function.
And that is the critical variable here. It's not about the hook, it's about the protocol he set. Ratna didn't ask for the difficulty to be lowered.
You don't want a handicap.
Zero. He didn't say, hey, judges, I have no hands, so maybe go easy on my plating. He engineered a new protocol to meet the standard that already existed.
Oh, wow. Yeah, that's a huge distinction.
It changes everything about how we see our own limitations. We look at a problem, launching a startup, learning a language, and we identify a hardware limitation. We say, I can't do X because I don't have Y.
I can't start a podcast because I don't have a professional studio. I can't run a marathon because my knees are bad.
Right, those are the error reports we log. But the source argues that the real translation of that sentence is usually, I don't want to find a new way to do X.
Oh, that's a direct hit.
It is, but it's meant to be liberating. If Ratna can engineer a way to peel garlic with a metal hook, then the argument that you can't launch your project because you don't have the perfect software,
Yeah.
it just collapses.
It reframes the whole thing. It's not, I can't. It's, I haven't built the interface yet.
Exactly. And the author says watching this was genuinely emotional for him, not out of pity,
No.
out of respect for the engineering. The source says the human spirit is the most powerful operating system there is.
Because it's open source.
Yeah.
We can modify it.
Because it's self-patching. Unlike a standard computer that just crashes when a part fails, the human OS can route around the damage. It can rewrite its own drivers in real time. If the hardware fails, if you lose your hands or your funding, the operating system can be reconfigured to run on whatever is left.
That is such a powerful image. It shifts the focus from what you lost to what you can build. So, okay, that's the physical layer, dealing with a permanent hardware change. But the newsletter then shifts gears pretty drastically, from a high-end kitchen to a chaotic football pitch.
We're moving from individual biomechanics to team psychology. But the engineering principle is the same.
So, to set the scene,
Huh?
the source is dated Sunday the 18th. So, yesterday was Saturday the 17th, the day of the Manchester Derby, Man United versus Man City.
A massive rivalry. One of the biggest in sports, really.
And the author is a Manchester United fan. Now, I don't follow the Premier League that closely, but my understanding is that leading up to this game, the system at Man United was crashing.
Crashing is being polite. The source says they just crashed out of the FA Cup. For anyone who doesn't follow football, that's like a major tech company's flagship product failing to launch.
It's a humiliating failure.
Systemic. So morale is on the floor, the fans are angry, the data inputs are all negative.
And now, right after that crash, they have to play their biggest rivals, City, who are a well-oiled machine.
A machine that usually takes them apart. So the predictive model for this match was basically zero. High anxiety, recent failure, corrupted confidence.
But, and this is why it's in the newsletter, United won. They actually won. The source calls it the Manchester Derby redemption.
Manchester is red, as the author puts it. But we're not here for the football analysis. We're interested in the mental engineering. How do you reboot a system that just crashed and immediately run a high-performance program?
Yeah, how does a team go from total failure to beating the champions in, what, a week?
It all comes down to memory management.
Okay, unpack that for me. Memory management.
In a computer, you have a cache short-term memory. It keeps recent data handy. But if that data is corrupted, if your cache is full of error logs from the last crash, the whole system gets glitchy, you get lag, hesitation.
So the FA Cup loss was the corrupted data sitting in the cache.
Exactly. If those players walked out against City with their RAM full of, we're terrible, we lost last week, we're going to fail again, they would have played with that lag. They would have been slow.
Well, they had to clear the cache.
They had to execute a flush. In sports psychology, they call it having a short memory. You miss a shot, forget it. You concede a goal, delete the file.
Kind of reminds me of that Ted Lasso be a goldfish line.
It's a cliche because it's functionally true. But from an engineering perspective, it's about bandwidth. You only have so much processing power. If 40% of your RAM is busy running a background process, analyzing last week's failure, you only have 60% available for the game in front of you. You will lose to a team running at 100%.
That's actually a terrifying thought for just, like, regular work life. If I have a terrible meeting on Tuesday and I'm still replaying it in my head on Thursday?
You are leaking memory. You are running a heavy background process that is eating up your CPU. You're slower, less creative, and you're more likely to crash again.
The author describes the win against City as a necessary dopamine hit.
Yes, and that's key. You can't just delete the bad files. You have to install new ones. The win provided a sister check, OK signal. It proved the machine still works.
So resilience isn't just about enduring. It's about actively generating a new signal to override the old one.
Exactly. Ratna generated a new signal by building a hook. Man United generated a new signal by winning. You have to create fresh data to overwrite the corrupted memory. You can't just think your way out of a corrupted cache. You have to do your way out of it.
I love that. You can't think your way out of a corrupted cache.
No.
Okay, so we've got the physical adaptation with the chef, the emotional reset with the football team. But the source layers in one more type of input. This one's a bit more intellectual.
Right, this is in the inputs section. The author mentions spending the week deep diving into Demis Hassabis.
The CEO of Google DeepMind, the guy who just won the Nobel Prize.
The very same. The author mentions a documentary, The Thinking Game, and connects it to a concept he calls the long game.
That feels like a bit of a sharp turn from the adrenaline of a football match. How does that connect to resilience?
It's about balancing your power sources. The football win, that's high glycemic energy, that's sugar. A massive spike of dopamine, it feels amazing, and it gets you through the weekend.
But you can't run a system on sugar. You'll crash.
You need protein, slow-burning fuel. And Demis Hassabis is the protein. His story isn't about a quick win on a Saturday. It's about working on a single problem like AGI or protein folding for 20 or 30 years.
So the author is deliberately curating his inputs to keep his own operating system stable.
Yes. He's acknowledging that to keep his mind healthy, he needs both. He needs the tribal, visceral excitement of the Derby to clear the short-term cash, to feel that we won energy. But he also needs the deep intellectual resonance of someone like Hassabis to set the long-term vector.
If you only have the short term, you're just reactive. If you only have the long term, you might burn out from a lack of feedback.
Precisely. It's a balanced diet for the mind. If you're only consuming short-term content TikToks, game scores, your attention span fragments. If you only consume dense academic papers, you might lose touch with the energy of the now. You need to engineer the mix.
Which brings us to the final and maybe the most meta part of this whole thing, the newsletter itself.
The bug fix.
So the source starts with, "Hello, friends, I'm back." And then it introduces a rebrand. The newsletter is now called The Weekly Commit.
For the non-coders listening, we should probably explain why that name is so important.
Please do.
In software, when you use version control like Git, a commit is the action of saving your changes. You write some code, you fix a bug, you commit it. It's a snapshot of work done.
Git commit. Yeah, it's a verb and a noun.
It is. But here's the brilliant part. The author admits he had a bug in his own life. The bug was inconsistency. He wasn't writing regularly.
I think we all have that bug. I have that bug with the gym, with calling my parents.
Right. We all do. But look at how he diagnosed the root cause. He didn't say I'm lazy. He said he was treating every newsletter like a product launch.
Oh, that resonates. The idea that if I'm going to send something out, it has to be perfect. The Steve Jobs iPhone reveal. Every single time.
Exactly. And in the software world, that's a death sentence. If you wait a year to ship your code because you want it perfect, the market moves on. The task becomes so scary, you just procrastinate.
So the fix was changing the framework from launch to commit.
You don't ship code once a year. You commit daily. That's the philosophy. By calling it the weekly commit, he's radically lowering the barrier to entry for himself.
It changes the definition of success. Success isn't, I wrote a viral masterpiece. It's, I logged my progress.
It's continuous integration. You push small updates. Maybe there are typos. Maybe the analysis isn't 100% done, but you shipped something. And because you shipped, you cleared the cache and you can work again next week.
It's the init commit for 2026, as he calls it.
And notice the vulnerability there. He's publicly stating, I had a bug, I fixed it, here is the patch. That's procedural resilience. He didn't just try to write harder or use willpower. He changed the system to make writing easier.
So if we zoom out and look at the whole picture, we've really mapped out a complete architecture for handling failure.
We have. It's a 3-layer stack. First, the physical layer with Ratna Tamang. When the hardware fails, you build a new interface. You rewrite the drivers.
Okay.
Second, the emotional layer with Manchester United. When the system crashes, you clear the cache so you can run the next process without lag.
Right.
And third, the procedural layer with the author. When the output is inconsistent, you change the deployment schedule. You stop trying to launch. You start trying to commit.
It's all the same lesson, just applied to different parts of the human experience. It's about refusing to accept that the error screen is the end of the program.
The error is just data. It's telling you something needs a patch.
I keep going back to that metal hook. It's so stark, so physical. It's not a metaphor for him. It's his reality.
It strips away all our excuses, doesn't it? We usually wait for a hardware upgrade. I'll be more productive when I get a new laptop. I'll be happier when I get that promotion.
I'll cook better when I renovate the kitchen.
Yeah. Ratna proves you don't need the upgrade. You need to patch the software to work with the hardware you have right now.
Which is the weekly commit mentality. Don't wait for version 2.0. Push the code you have today. So here's the question I want to leave everyone with as we wrap this up. We're halfway through January. The new year, new me energy is probably starting to fade a little bit. Reality is setting in.
The bugs are starting to appear in the new
The
resolution.
bugs are definitely appearing. The hardware limitations, your schedule, your budget, your energy, they're showing up. So if you stopped waiting for a hardware upgrade and instead focused entirely on rewriting your interface, what is the very first bug you would fix today?
What's in your first commit?
Is it sending that email you've been avoiding because you don't have the perfect answer yet? Is it doing a 15-minute workout instead of waiting for the perfect hour at the gym?
Just push the code. Fix the bug.
Get push,
Get-
get push. Thank you all for committing your time to us today. This has been a really inspiring one to break down. Hopefully it helps you debug whatever you're facing this week.
It's been a pleasure.
We'll catch you in the next build. Signing off.